Hello everyone. Today we're going to discuss the automotive development process. How does a vehicle evolve from a simple idea in someone's mind into a real product on the road? The first phase involves understanding how a prototype goes from concept to creation. The initial step is understanding the market. So, the process begins with market research. Market research involves analyzing market trends. For example, we might see rising demand for electric vehicles in the mid-premium segment. In response to such trends, the company must identify opportunities and challenges. Pain points are evaluated next. Issues like slow charging and limited range become important to solve. After that, we define the functional requirements. For instance, customers may want a minimum of 400 kilometers of driving range and fast charging capabilities. Emotional drivers are also taken into consideration. For many buyers, owning an electric vehicle reflects a commitment to sustainability, so brands must address that sentiment as well. Once these factors are evaluated, we can define the product. This is where we clearly outline the specifications and expectations for the vehicle. After the product definition is complete, a feasibility study is carried out. This study evaluates the economic feasibility and also the practicality of using a specific technology. The study assesses whether the required technology exists and whether competitors already offer similar solutions. This helps determine if the product is technologically and financially viable. Next comes the business case. This is where management decides whether the project should proceed. Since they would be investing significant resources, the decision must be made carefully. The costs involved are substantial, and approval is not taken lightly. Once approved, the design phase begins. Designers start by creating mood boards and preliminary sketches. A mood board sets the tone and direction for the design language, reflecting the company's values and style. After that, rough sketches are created and continuously refined. Over time, the team produces hundreds or even thousands of drawings until a direction is agreed upon. After the sketching phase is complete, the work transitions into digital formats. More detailed digital renders are produced. After the rough sketches, these refined visuals show how the vehicle will look in three-dimensional space. They may still resemble drawings, but now they incorporate realistic proportions, lighting, and more defined details. Every component and subcomponent is designed. Color options are experimented with. The design team evaluates multiple directions, including infotainment layouts and interior themes. Once the rendering stage reaches maturity, the project moves to 3D modeling. At this stage, the team develops 3D models in collaboration with other departments. Engineers from electrical, mechanical, and other divisions work together with the designers. They communicate constantly, advising on what can be manufactured, what needs modification, and what is structurally practical. These iterative discussions and modifications lead to a finalized design. The finalized design is translated into detailed models viewable in the company's CAD systems. In the CAD models, every millimeter of the vehicle is precisely defined. Once the surfaces, geometry, and three-dimensional forms are finalized, the process moves to clay modeling. Clay modeling has been a crucial step in the automotive industry for nearly a century, and no major company skips it. Clay modeling helps designers perfect shapes and observe how surfaces capture light. Industrial clay, plasticine, is heated and applied to scaled models. These small models are scanned back into digital systems so engineers can verify that everything still matches the intended design. Adjustments are made repeatedly. Several small clay models are produced before moving to a full-scale clay model. A full-scale model uses foam blocks as a base, covered with clay to form the vehicle's exterior shape. A CNC machine may be used to remove large portions of clay, establishing the rough surface. Earlier, everything was sculpted manually. Today, much of it is computer-assisted. Once the rough form is created, skilled sculptors refine the model. Under the supervision of the designer, they shape the surfaces until they achieve the correct forms. Designers use thin black tape to mark lines and define visual elements on the clay surface. Teams compare these reflections with digital renders to ensure consistency. Meanwhile, engineers may perform aerodynamic evaluations directly on the clay model. Since clay can be reshaped easily, modifications can be made immediately. Reflective films may also be applied to observe how real light interacts with the shapes. A surface layer is applied on top of the clay to produce a paint-like reflective finish. This helps designers visualize how the final painted vehicle will appear under real lighting. "3D printing is also heavily used during this phase. Many plastic components can be printed quickly and fitted directly to the clay model, which speeds up prototyping. Once the clay model is fully approved, the entire object is scanned again. These scans enable engineers to build internal structures to support the exterior design. What we see on the outside are only surfaces. Structural components must hold them together. For example, a vehicle door has two layers, an external panel for aesthetics and an internal panel that provides strength and support. After this step, the process moves into prototyping. Prototypes can vary widely based on purpose. Some prototypes are created only for display. Others are functional test vehicles. Some are built to show journalists but are not meant to be driven. The design of the prototype depends entirely on its intended use. For example, a show-only prototype is built for visual impact, not performance. In this type of prototype, every exterior part must be manufactured, even though it won't be used on the road. Established companies like Audi have significant advantages here. Many prototypes showcase a brand's long-term vision. Examples include Rolls-Royce or Polestar concept cars. These show possible future directions. Some prototypes are nearly production-ready but have incomplete interiors or no working drivetrain. These prototypes can still be shown to the media to gather feedback. Returning to our example, a one-to-one concept prototype involves custom manufacturing. Every part, every surface, is made specifically for that model. None of the parts come from a standard assembly line. This makes prototyping extremely expensive. After the prototype is built, it is revealed to the public. Feedback is collected from journalists and industry analysts. The result is the concept prototype. Established manufacturers benefit greatly in this process. They have standardized procedures. Brands like Audi already have internal protocols and workflows that have been refined over decades. They also have a deep parts supply network. A logo, a steering wheel, an infotainment component, these may already exist in other models. If something doesn't need to change, they can reuse it. If something must be created, suppliers already have the capacity to produce it quickly. This gives existing manufacturers a massive advantage over startups. New companies must build their entire supply network from scratch. They have no existing part inventory, so everything has to be developed anew. Established companies also have the advantage of infrastructure. Their design studios, clay facilities, 3D printers, virtual reality systems, and prototyping tools already exist and have been paid off through years of use. Startups must build this infrastructure while designing a product, making progress slower and more expensive. Sometimes the lack of infrastructure delays development because the company must first create the tools needed to continue. Another major advantage for existing OEMs is access to real customers and real feedback. Since they already sell vehicles, service centers provide customer insights. They know what issues customers face, what improvements are expected, and what features are valued. They have a strong understanding of real user expectations. Startups, on the other hand, do not yet have customers. They can collect feedback only after they begin selling their vehicles. Until then, they operate without real consumer input. I hope this episode was useful for you. In the next episode, we will dig deeper into prototypes, their testing, and manufacturing processes. See you then. Happy motoring!